This PowerPoint will demonstrate how to find sides and angles using the cosine law. In the top right-hand corner of the page, you'll see a triangle here, and this could be literally any triangle. It could even be a right triangle, a triangle with all acute angles, or even an obtuse triangle. And as I said, the cos law can be used to find angles or sides. The versions of the cosine law to find sides are the three green ones in the top left-hand corner here. In order to find a side using the cos law, you need two sides, the other two sides, and the angle between them. So if I want to find side A, I need to know sides B and C, and angle A being the angle opposite the side I'm trying to find. And so the cosine law looks like this. If I want to find side A, in this triangle, a squared would equal b squared plus c squared minus 2bc. Notice these are the same two sides as these sides here. And that's also multiplied by the cos of a. Again, the angle you need to know in order to find side A is angle A. If I want to find side B, I need to know sides A and C, the other two sides, and the angle opposite the side I'm finding. And similar for side C. Now, the cosine law can also be used to find angles. And you'll see an example of that in the second page. Cos A, if I want to find angle A, cos A is b squared plus c squared minus a squared over 2bc. All these three red formulas are the top three formulas solved for cos A or cos B or cos C. And so I need three sides to find any angle. Notice that if I'm finding angle A, it's side A I'm subtracting here squared. If I want to find side B, it's a squared plus c squared minus side B squared. Again, B is the side opposite the angle you're trying to find. Notice the two sides in the denominator that are multiplied by the 2 are the same two sides that are here. In the first example, we're given triangle BCD, two sides, and the angle between them, and asked to find side D. So this is the basic scenario for using the cosine law to find a side. You have the other two sides and the angle between them. So here now we can use this cosine law to find side D. Side D would be this one here, opposite angle D. So we write out the cosine law. And so D squared would equal b squared plus c squared minus 2bc cos D. Again, cos D, D is the angle we need in order to find side D. So filling in the values for side B, side C, and angle D, D squared would equal 14.9 squared plus 18.3 squared minus 2 times 14.9 times 18.3 times cos 22. Again, side B is the 14.9 and side C is the 18.3 feet. And then these are the B and C sides here. And the cosine of angle D, that's angle D, opposite the side we're finding. Now, we would evaluate 14.9 squared and 18.3 squared and add those. And remember your order of operations, we have to do 2 times 14.9 times 18.3 multiplied by the cos of 22. And then that gets subtracted from the sum of these two squares. This whole calculation here will simplify to about 51.269, etc. Now, D squared equals that value. So to find D, we would take the square root of that 51.269, etc. number. And so side D works out to be approximately 7.2 feet. That's how long side D would be. Flipping over to the second page, we're given an example, and sometimes you'll be asked to draw the triangles. And so that's another thing we're going to do here, aside from using the cos law. And in this triangle ABC, we're going to draw a triangle, and I'm going to draw it approximately to scale. We're told that angle A is 36 degrees. So I'll put my angle A there. That angle is around 36 degrees. And I'll put my B and C on the other vertices. Side B is 17, so that's the side opposite angle B, which would be in the top between A and C. And side C is 14, which is opposite angle C, or between the AB vertices. Now we're asked to solve triangle ABC, which means to find all the unknown sides and angles. So we need to find angle C, angle B, and we also need to find side A here. Now, this is the same kind of scenario as we had on the previous page, whereas we're going to use the cos law to find side A first, because we have up here the two sides and the angle between them. And so I can use the cosine law in order to find this side over here, which is side A. So a squared would equal b squared plus c squared minus 2bc cos A. So that's the cosine law to find side A. And side B is 17, side C is 14, and the angle A is 36. So we'll substitute those values into the cosine law. And once again over here, remember your bed mass, you have to multiply the 2, the 17, the 14, and the cos of 36. And then that gets subtracted from 14 squared plus 17 squared. On the right side, this whole calculation will simplify to 99.9079 approximately. Keep several decimal places, don't round that too quickly. So a squared equals that. So to find a, we would take the square root of that 99.9 number. And so a works out to be almost exactly 10. So a is about 10 centimeters. So we'll label that in the diagram. Now, I'm next going to find one of the angles B or C. And I want to show you how to use the cosine law to find an angle. I will do this another way as well, but I'm going to find angle C. I could have found angle B just as easily, but I'm going to choose to find angle C. So the cosine law for angle C would be cos angle C is equal to a squared plus b squared minus c squared. Notice that the side subtracted and squared in the end is the side opposite the angle we're finding. In the denominator is 2ab, 2 times the product of these two values, sides that are squared here. And so we substitute in place of a, b, and c, the 10, 17, and 14 in the formula. And so we evaluate the entire right side here. So you have to do 10 squared plus 17 squared minus 14 squared in the numerator, and 2 times 10 times 17 in the denominator. And so in the numerator, 10 squared plus 17 squared minus 14 squared is 193. 2 times 10 times 17 is 340. And so we divide those to get about 0.5676. So cos C equals 0.5676 to 4 decimal places. And then we want to find angle C. So we would take the inverse cos of that 0.5676 value. And so C works out to be about 55 degrees. So in the diagram we can put 55 degrees by angle C. Now we do know 2 of the 3 angles now. So we can find the third angle. We don't have to use the cosine law again to find angle B. We could just use the fact that the 3 interior angles add to 180. And so angle B is 180 minus 55 minus 36. So angle B works out to be approximately 89 degrees. And you'll notice that it did look like almost like a right angle triangle. That's why, because B is almost 90 degrees. Now I want to point out that you did have another option here, aside from using the cosine law at this point. You could have used the sine law to find angles B or C, because you had an angle side pair, the 36 degree angle A and the 10 opposite it, and you had these two sides, so you could have used the sine law to find angle B or C. So I'm going to do that calculation. So this is an alternate solution besides using the cosine law. So if I wanted to find angle C using the sine law, I could have used sine C over side C is equal to sine A over side A. And so side C is 14, angle A is 36, and side A is 10. And so we cross multiply to find what sine of angle C equals, and it would be 14 times the sine of 36 divided by 10. And so we would evaluate this quantity here. It works out to be about 0.8229. And then we take the inverse sine of 0.8229, and we get about 55 degrees, which of course should be exactly the same as what we got over here. So that's another alternate solution. Of course, once we found the 55, we could have done 180 minus 55 and 36 to get, again, the B is 89. And that's the end of the cosine law lesson.